Okay, this is your 6th video and it is about predicting the products of reactions. You should have learned this in honors. There are 5 classes of reactions: synthesis, which is also called combination, decomposition, single replacement, double replacement, and combustion. Synthesis or combination reactions are generally written as A plus B forms one product of AB. You will know it's a synthesis because you usually have 2 reactants forming one product. When you don't have the products, you'll notice it because it's got 2 elements as your starting reactants, or it's going to include water and either a non-metal oxide or a metal oxide. If it's a non-metal oxide and water, it'll form an acid. If it's a metal oxide and water, it'll form a base. When you write the product, make sure you use it or you do it correctly by swapping and dropping the charges. Here are some practice questions. Now I know one is a synthesis reaction because it's 2 elements, aluminum and oxygen. Now you have to have a periodic table next to you, so pause it if you do not. Aluminum has a charge of 3 plus, oxygen has a charge of 2 minus. When you swap and drop, you get Al2O3. Balance it, and you end up with coefficients of 4, 3, and 2. In the second one, again, 2 elements. The only thing they can do is come together. The reason there's a Roman numeral 2 is because copper is a transition metal and can have variable charges. This 2 is telling you it's a charge of 2 plus. Oxygen is always a 2 minus. When they are the same and you swap and drop, they reduce. Balance it, and you end up with the coefficients of 2, 1, 2. Third one, magnesium is a 2 plus. Nitrogen is a 3 minus, swap and drop, and you get Mg3N2. Then balance it, you need just one coefficient of a 3. Now, 4 and 5 are tricky because if I wasn't telling you their synthesis, you guys most times will tell me, oh, it's double replacement. It's not. Notice the location of the water. The water is a reactant. When water is a reactant, you need to think about synthesis as a possibility. In this case, you have a nonmetal S bonded with oxygen. That's a nonmetal oxide. A nonmetal oxide and water will make an acid. Acids have H in the front. If you smush together everything else in the problem other than the H's, you end up with sulfate. Sulfate has a charge of 2, hydrogen has a charge of 1. You end up with sulfuric acid, and it is already balanced. In 5, you have water again. This is a metal, calcium's a metal, with oxygen, so you know that you're going to make a base. Calcium has a charge of 2 plus, hydroxide has a charge of 1 minus, swap and drop, and there's your base. Balance it, and you'll notice that it is already balanced. Decomp is the opposite of synthesis. It's when a compound is breaking down to form smaller products. It will occur when a compound breaks down usually into its elements, but there are special cases that you must not only be aware of, but you must memorize. For example, you must know that carbonates will decompose to form a metal oxide and carbon dioxide. Hydroxides will decompose to form a metal oxide and water. And the whole chlorate family, so that means chlorate, chlorite, perchlorate, and hypochlorite will break down to form a metal chloride and oxygen. So all of these are clearly decomposition because they all start with one compound as the reactant. In number 1, there's nothing special. There's no carbonates, hydroxides, or chlorate family. So all you do is break it up. Hydrogen plus iodine. Now both of these are diatomic, so they have to be written correctly, and then you balance it. The second one is also simple. Split. Copper and oxygen. Do not bring this 2 over to the copper. It is not diatomic. The oxygen needs a 2 because it is diatomic. Balance it, and that is what you end up with. Number 3, carbonate. This is one you must know. Carbonates will break down to form a metal oxide. Your metal is cadmium, which is always a charge of 2 plus, and it's going to be bonded with an oxide, which is oxygen. Oxygen is also a 2 minus, so when you swap and drop, they cancel and you end up with CDO. And then I told you the other product is carbon dioxide. You can check, but it's balanced. The fourth one contains a chlorate. Chlorates will break down into metal Chlorates will break down into metal chlorides. Your metal is K. K has a charge of 1 plus. Chlorine is chloride. It has a charge of 1 minus. And you'll also make oxygen. Balance it, and this is what you end up with. Hydroxides, the last one, will break down into metal oxides and water. The metal here is lead. Lead has a variable charge, but when you look at how it's bonded with two hydroxides, you can figure out that in this case it's a 2 plus. The lead will bond with the oxygen to form PbO, and then you're left with water. When you balance it, you'll notice it is already balanced. The next type is single replacement. Single replacement can occur in one of two ways. If A is a metal, in the first one, it will replace B and bond with C, so that's the first case. In the second case, if A is a nonmetal, it'll switch with C and bond with B. Now, single replacement will occur when you have an element and a compound reacting together to form a new element and a new compound. You will need to use the activity series to decide if a reaction will occur between two metals. So for example, if, lithium is A, and let's say B is zinc chloride. B is zinc and then C is chloride. Now, that reaction will happen because the lithium, which is by itself, is above zinc. Now, conversely, if zinc was A and lithium was B, then it would not happen because zinc is not above lithium, and this would be no reaction. Okay? Oh, I forgot to mention, the halogens, you will not see this portion of the activity series a lot of times on a test. The reason is, look at your periodic table. It's giving you the activity series. Fluorine is more active than chlorine, which is more active than bromine, which is more active than iodine. It's on your periodic table. You don't need this half of the chart. All you need is the metal side. Single replacement. Now, for single replacement practice, make sure you pay attention to which one is the single element. It doesn't have to be listed first. So in number 1, chlorine is by itself. Chlorine has a charge of 1 minus. So you must figure out what it's going to be switching with. Magnesium has a charge of 2 plus, and bromine has a charge of 1 minus. So the chlorine and the bromine are going to switch because they're both negatively charged, not because they're both 1 minus. They are going to switch, but only because they're both negative. They don't have to be the same amount of negative. Switch them out. Magnesium goes first because it's positive. Swap and drop with the chlorine, and you end up with MgCl2. And now the bromine's by itself, and because it's diatomic, it requires the 2 as well. Now, zinc has a charge of 2 plus, hydrogen has a charge of 1 plus, and chlorine has a charge of 1 minus. The zinc is going to switch with the hydrogen. Check your activity series. Zinc is above hydrogen, so it will happen. So the zinc will form with the chlorine to make ZnCl2, and since hydrogen is diatomic, it requires a 2. And then you balance it by putting a 2 in front of the HCl. Now the third one, copper, they're telling you is a 2 plus, hydrogen is a 1 plus, and then the entire acetate is a 1 minus. Copper and hydrogen are going to switch. Copper is not above hydrogen when you check your activity series, so it's no reaction. Do not write the products, do not balance. The last one, zinc is a 2 plus. Lead, in this case, if you look, nitrate's a 1 minus, which means the lead is a 4 plus. Switch the 2 positives, you end up with ZnNO3 2 plus Pb. Pb does not get a 2, it's not diatomic. You end up balancing it, you need a 2 here. You need a 2 in front of the zinc, and then you need a 2 over here in front of the other zinc. Double replacement is when you have 2 compounds. They're 2 ionic compounds. Basically what happens is they switch their partners, either switch the metals or the positives, or you can think of it as switching the nonmetals or the negatives. You're going to make 2 new compounds, and one of them is either a liquid, a gas, or a precipitate. The other thing I'm going to tell you about these is to watch out for the formation of carbonic acid. carbonic acid immediately breaks down into water and carbon dioxide, so it actually makes two products instead of one. Okay, so for some double replacement practice, label the charges. Sodium's a 1 plus, iodine's a 1 minus, calcium's a 2 plus, chlorine's a 1 minus. Switch them. The Na is now with the Cl. They are both charges of 1, so they cancel. Do not look at the subscripts. Calcium is now with iodine. Calcium must go first because it's positive. Iodine has to go second. Swap and drop, you end up with CaI2. Then all you have to do is balance. 2 chlorines, 2 sodiums, and that fixes the iodine. Then, for number 2, sodium has a charge of 1 plus. Carbonate, don't forget to memorize, 2 minus. Hydrogen's 1 plus. Phosphate's 3 minus. Swap them, and the sodium is now with the phosphate. So when I swap and drop, I get Na3PO4. And then the hydrogen is now with the carbonate. Oh, carbonic acid. I don't make carbonic acid. It immediately breaks down into water and carbon dioxide. So make sure you catch that. Balance it. I'm going to need a 2 here and a 3 here. I'm going to need 3 over here. I'm going to need 2 here. That means I have 6 hydrogens, so I must need a 3 here. That gives me 3 oxygens, 6, 9. Yep, we're all good there. And then the last one, calcium's a 2 plus, sulfate's a 2 minus, aluminum's a 3 plus, chlorine's a 1 minus. I'm going to come down here for space. I end up making calcium chloride and aluminum sulfate. Balance, I need a 2, a 3, it looks like a 3, and I'm all set. Last type, combustion. Now, in combustion, in honors, you guys probably heard that combustion was only when you had a hydrocarbon reacting with oxygen to make carbon dioxide and water. Now, this was very simplified. It is combustion, but the actual definition of combustion is anything that involves O2. So anytime something burns, which means react with oxygen, it's a combustion reaction. Combustion reactions are always exothermic, and not all of them will release carbon dioxide and water. So if you look at the example here, magnesium is burning in oxygen to form magnesium oxide. It's like a synthesis reaction in a way, but it is also considered a combustion reaction because you're reacting with water, or reacting with oxygen. So don't limit your definition of combustion to only something with a hydrocarbon producing carbon dioxide and water. So here are some examples. I see that it's something made up primarily of carbon and hydrogen. I react it with oxygen. I'm going to make carbon dioxide and water. Then I have to balance it. 2 carbons, 2 carbons. 6 hydrogens, I need a 3 here. That gives me 4 and 3 is 7 oxygens. I cannot divide 7 by 2 to get a whole number. So I used to teach my students, when in trouble, double. What that means is double the very first thing you started with. So I started with carbon. There are now 4 carbons. So go back, change it. There are now 12 hydrogens. Go back, change it. I now have 6 oxygens and 8 oxygens, which is 14. And then I can put a 7 here. Now in number 2, it's still combustion because I'm reacting with oxygen. But because you can't predict the products, I gave it to you. So all you have to be able to do is fill them in, okay? 2 carbons, 2 carbons, 6 hydrogens, means I need a 3 here, 1 sulfur, and now all I have to do is the oxygens. On the left, I can easily change those number of oxygens. So let's see how many I have on the right. I have 4, 7, and 2 is 9. That's not going to work. When in trouble, double. Put a 2 here. I now have 4. I now have 12 hydrogens, so I need a 6. I now have 2 sulfurs. And now retotal up your oxygen. So I'm going to, give some space here. It's hard to do in a mess. So you now have 8, and 6 is 14. and 14 and 4 is 18. No, is that right? 8 and 6. 14 and 4 is 18. Yeah, sorry. And so then you need a 9. The last one, obviously combustion, you need CO2 and H2O. Fill them in, 6 carbons, 12 hydrogens. That's 12 and 6 is 18 oxygens. But notice you do have 6 here. So 6 plus what will give you 18? 12, of course, so you need a 6. Alright, last slide for a little bit of mixed practice. Number 1, first thing to do is to decide what type of reaction it is. You only have one reactant, therefore it is decomposition. Notice you have a carbonate. Carbonates will break down to form a metal oxide and carbon dioxide. So you can write the carbon dioxide right away if you want, and then you need a metal oxide. Aluminum has a charge of 3, oxygen has a charge of 2, swap and drop and you end up with Al2O3. Check the balancing. I've got 2 aluminums. Yeah, we got problems with the oxygens. So I'm going to double this, and we end up with 4 aluminums. So 4 aluminums, 6 oxygens, no, 8 oxygens. That's not going to work. Let's see. Oh, I see what the issue is. I miswrote this, you guys. I'm sorry. In your notes, you're going to have to change this. It's supposed to be Al2CO3, 3, which is why it doesn't make sense. You form CO2 and Al2O3. Now you should be able to balance it just fine. You have 2 aluminums and 2 aluminums. You have 3 carbons, so you need 3 carbons, 6, 9. Now you're all good. So I apologize for the mistake. Please fix it. Thank you so much. Number 2, I've got something that looks kind of like a hydrocarbon. It's got a lot of carbons and hydrogens. It's reacting with oxygen. That signifies to me that it's probably combustion. I'm going to go ahead and balance it. I have 6 carbons, so I need 6 carbons. 10 hydrogens. I have 12, and 7 is 17 oxygens. Before you say, oh, that's not divisible by 2, notice that you have 3 here. So 3 plus what will give you 17? You need 14, so you need a 7 there. Next one. Now, in the next one, you are trying to do a bromine with a sodium iodide. It looks like you have an element and a compound. That tells me this is single replacement. The bromine has a charge of 1 minus, the sodium is 1 plus, and the iodine is 1 minus. Can bromine replace iodine? Check the chart, and it can. Put the Na first because Na is positive. Since they're both 1, they cancel. And the iodine is left by itself, but since it's diatomic, it needs a 2. For number 4, you have 2 elements coming together. That must be synthesis. Swap and drop their charges, you get Rb2O, and it is already balanced. And number 5, it's double replacement because I have 2 compounds. I get LiNO3 plus CuOH2. Go ahead and balance it, and a 2 and a 2. And for the last one, you're going, oh, that's double replacement. And you should think again. You have water. We did this one earlier. If you have water and a nonmetal oxide, you make an acid, H2SO4. All right, that's it for this one. Good luck. Get your stuff done. I will see you when school starts.